I was like a little countdown.
You're watching the Vice Channel.
Da 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 da.
I thought I was gonna say it.
Yeah, bro. You gotta say it.
Thank you. All right. Today we're doing probability with independent events, meaning one event doesn't necessarily have to do with the other. For example, what is the probability that you will randomly pick any heart from a standard deck of cards and get tails when flipping a coin? One has nothing to do with the other, so they're separate, so you just multiply. The probability of getting a heart is 1 out of 4, or 0.25. Probability of getting tails is 1 out of 2, or 0.5. Just multiply. 0.25 times 0.5 is 0.125. What is the probability of randomly selecting the index finger on your left hand and rolling a 4 on a die? Okay. Selecting your index finger is 0.2, 1 out of 5, right? Rolling a 4 is 1 out of 6, or 0.16. 0.2 times 0.1666666 is 0.0333333. Now, here's a weird one. What is the probability that your mom will make dinner for you given that she's not mad at you for forgetting to turn in your assignment? So there's two separate things here. And not only that, the probability that your mom will make dinner, say, is 0.8. Probability that you forget to turn in your assignment is 0.46. The probability of A given B, the probability that your mom will make dinner, is going to happen regardless of B. B already happened. So we just say it's the same as the probability of A. So we just put that is the answer, 0.8. That's it. When you probably A given B like this, it's just that is your answer. Same thing here. Out of 20 marbles, 8 are red. What is the probability of randomly drawing a red marble given that you flipped the coin and it came up tails? See, that's the thing. It already came up tails. It doesn't matter what that probability was because you're just now drawing a red marble, the probability being 0.4. 8 out of 20 is 0.4. So the probability of A, given that B already happened, is the same as the probability of A. That's it, 0.4. Okay. Now in the rest of these, okay, what you're going to do is you're going to follow a formula. Okay. Formula is going to be given. If you don't take a picture here of the formula, then just click on Show Example, and it'll show you the formula on Delta Math. Okay. Probability of A is 0.31, probability of B is 0.7, probability A and B is 0.267. Find the value of probability B given A to the nearest thousand. Now look at this. All you have to do is this one divided by this one. Well, so why do they give you this 0.7? I don't know. Don't worry about it. All right, just do 0.267 divided by 0.31 and get 0.861. Same thing here. You gotta find probability B given A. You're gonna do probability A and B, which is this 0.198, divided by probability A, which is 0.24. I don't even need this that they give me. Okay, divide on a calculator. You get 0.825. Okay. Over here again. Instead of B given A, this one's A given B. Okay. Still, they give you the formula. Probability of A and B divided by probability of B. All right. Probability of A and B is 0.43. Probability of B is 0.5. Divide. 0.43 divided by 0.5 gives you 0.86. Okay? Over here. All right? Now, Probability A, 0.2. Probability B, 0.36. Probability A and B, 0.152. Find the value of the probability of A or B nearest thousandth. Follow the formula. Probability A or B is probability A plus probability of B minus probability of A and B. Okay? So we just follow 0.2 plus 0.36 minus 0.152 gives you 0.408. That's it. Okay? Over here is a little bit funny, but don't get freaked out. All right. Here, to find probability of A or B. All right. We need probability of A plus probability of B minus probability of A and B. But in this problem, we're looking for the probability of A and B. But I have to use this formula where it doesn't say probability A and B. It's over here that I gotta find. Okay, so I'm gonna fill in all the numbers I have. I have this number. I have this number. I have this number. I don't have this number. Fine. I'm going to add these two together to get 0.81 and subtract 0.81 from both sides. So I get negative 0.225 equals negative probability of A and B. Divide by -1 and my answer is 0.225. You've been watching the Weiss channel.